Hello friends, this is Shravan Kumar Manthri. Welcome to our channel CSE GURUS. Moving on to the next one, longest common subsequence. That is a problem number 1143 given in Leetcode. So we'll see what is this concept. There are two strings will be given. One is like text1 and text2. You have to return the length of their longest common subsequence. So what is that longest common subsequence? First of all, we have to know the difference between substring and subsequence, right? So let us suppose if I take here A, B, C, D, E. So I can say, let us suppose I'm writing here A, B, C, D, E. Substring means you can say, let us suppose A, B, B, C or A, B, C. Like this, you can say A, B, C or A, B, C, D. All are substrings. I can say the subsequence is, of course these are all subsequence. Not only that, AC is also a subsequence. Okay, ACD is also a subsequence. AE also a subsequence. BC is also a subsequence. And B and D is also a subsequence. But CA is not a subsequence. DB is not a subsequence. DA is not a subsequence. Hope you did get this one. So subsequence means there is no need to follow the continuity. That means it's not about continuous order. It may not be. Of course it may be, but it may not be also, then I can say. But whereas in substring, you must follow the continuous. Okay, in A and C you cannot say substring, right? But A and C you can say it is a subsequence. But C and A you cannot say it's a subsequence. Of course it's not a substring also. So you may not follow the continuity, but you have to follow the relative order. So that is what about subsequence. So relative order means the positions should be in increasing order. When you take, let us suppose if I take A, C, E is a subsequence, means let us suppose it's a position 1, 2, 3, 4, 5. So increasing order 1, 3, 5 like this. But what about if I say AEC? So 1, 5, 3. It's not an increasing sequence, right? So this I cannot say it's a subsequence. Okay, so that is what about subsequence and substring. So hope you did get this one. So what about substring and subsequence? So two things to be remembered. Substring means continuity to be maintained, and of course there is a relative order. But in subsequence, continuity may not be, but definitely a relative order should be there. So that is what here it is given, two texts, and we have to return what is that the longest common subsequence in a given string. Let us suppose a subsequence of a string is a new string generated from original string. Of course whatever I explained here, that is what I explained here. ACE is a subsequence of ABCD, but AAC is not. So of course you can take like this also. If I take ACE, you can match it like this, then there should not be any intersections. Okay, but whereas if I take AEC, so A, E and C, so there is an intersection. So definitely this string is not a subsequence of this one. So like this we can answer it simply by checking like this. So now what is our question actually? So what we need to find a common subsequence. Of course definitely should be common for both the strings, we know. Okay, so but we need to find what is that common subsequence and what is the length of the common subsequence. Okay, so we have to find that. So here we can have, let us suppose if I take A, B, C, D and AC, what is the length of the common subsequence? Longest one you can see here. What is the longest one? You can see ACE, which is the length 3. Okay, ACE is a common subsequence. You can see, of course here if I take ABC, both are same, that's why directly I can say common subsequence is 3. And what about this one? ABC and DEF, there is no common character also. So directly there will not exist any subsequence, that's why it is 0. So there is no such common subsequence. So you can take some other examples here. I'll take interest and I'll take test. Okay, I'll take test, interest. So you can see T and T, E, S and T. Okay, the length is 4. right? I'll take, of course, nest. So all are lowercase, right? I'll take all are lowercase, nest. Of course, yes, the longest one is 4. But the next one I want to take here is rest. So R E S T. So there is a crossing. So if I want to find to this one, what is the longest one? Can you say it is 4? No. Why? Because there is a crossing. It's not with 4. You can check it out with maybe less than 4. So you can start, you can go with this, like it follows like on order, like I with R, I with E, next I with S, like this. You can take anyway in naive approach, N with R, like this. Okay, if I take like this, you may get the complexity. Anyway, we'll discuss about that. So now you can see, if R with R, it's not, we are getting anyway, I have to ignore this one. I'll start with E, E with E, S with S, and T with T. Yes, there is no intersection. So that's why the longest common subsequence for rest is 3. Okay, for nest and test, you will get for these two is 4. So that is what about longest common subsequence here. So we'll see now what are the possibilities, how we'll get the answer. And if I go with the naive approach, of course, in a naive approach, what you need to check it out. In naive approach, every character you need to check it out, character to character. Of course, it's a subsequence. It is not a substring, means you have to check it out like with AB, AC, AD, AE also, all are. So like this, if I check it out, if n is the length of the string, okay, so now you need to check it out. If length of the string with less number of characters, definitely you have to go for 2 power n times. So 2 power n times you have to check it out. So that's why the complexity goes exponential, 2 power n. Is there any solution with a non-exponential? So definitely we have with the dynamic, where the complexity will be only n square. So we'll see what is this one. So dynamic approach, how it will be n square, and we'll see how to get that answer. Okay, so here I'm taking longest common subsequence using dynamic programming approach. I go for bottom up approach. I have taken 2 strings, S1, S2. I'll try with test. Okay, so what should be our answer? Anyway, we know the common subsequence is, with the longest one is 4, which is our test. Every character will be a common subsequence, comes under common subsequence. So we need to follow these 2 rules enough. Okay, if both are equal, this formula, otherwise this formula. Okay, so how to apply, we'll see directly. Okay, I have taken table. Okay, yeah, here I need to take the each and every character. Of course, we need to take the index from 0 here and 0. I have taken here a 0. Why? Because anyway we are not supposed to take the null character, we are not taking. That's why we are taking for better understanding. So I starts from here, INTERST, interest, and here test. Okay, anyway I'll take this length, TES and T. So like this we need to take why we started with 0 and 0 means to get the base condition. So anyway initially, so what is the longest common subsequence means you will get it as 0 without taking anything. So that's why all are 0 here. Yeah, so this is what initial values we can take. And now we have to go with the formula. First thing, if S1 of I is equals to S2 of J, so you can check it out here T and here I. So T and I are the same? No. So that's why you have to go to the else part. What is that else part? You can see LCS of, what is our LCS of this value is equals to maximum of. So there you can see actually what happens here. LCS of I minus 1. What is I value 1? J value also 1 means 0, 1, comma LCS of 1, 0. So the meaning is here is very simple. So when you want to find for this one, you are checking for the 0, 1. 0, 1 means this part, and 1, 0 this part. So maximum of these two you are finding. So why this maximum of these two? That means if I and T are not equal, then I am starting with either I'm checking for this one n with, okay, 0, 1 means n with the remaining, or I with the remaining. So that is what 0 1 means starting with here, 1 0 starting with this one. So either you have to increment this one or you have to increment this one. So that is what happens here, you can see. So either checking with this one I with E, okay, like this we are checking. So here you can see LCS of 0 1 is 0, here was 0 0 0, here it is 0, right? The maximum is 0. Now you can see the next one, T and N, here both are not same. Again going to this one. So what is this one? 1 and 2. So 1 and 2 means again you will get, like if you go for the formula, you will get what is the maximum of these two. Indirectly you can say anyway. So here it is 1 1 minus 1 0, here it is 2 0 2. What is 0 2? This one. What is here? 1 1. So this one. So maximum of these two. So 0. So again next T and T, now they are equal, you can see. If they are not equal, then maximum of these two you can see. But here T and T both are equal, this condition is satisfied. So now you can see what is this one? 1 plus. So 1 plus, so what we need to write? 1 plus LCS of I minus 1 comma j minus 1. What is I minus 1? Here you can see 1 3, I minus 1 is 0, j minus 1 is 2, right? So 1 2, so 0 2, so this value. So that's 1 plus 0, which is 1. So here I'll write 1. Okay, now we can conclude like this. So if characters are matching, not matching, check for maximum of these two. If characters are matching here, only 1 plus what is the previous value here in the top left diagonal, I mean in the previous diagonal on the top in the left. Okay, yeah, here also you can see. Now T and E not matching, so what you need to do? Maximum of these two, 1 and 0, maximum is 1. Now here T and R not same, so maximum of these two 1. Now T and S not equal, so maximum of these two 1. Now T and T, yes they are matching. Now what you need to do when it is matching? 1 plus previous value, this value. So 1 plus 0, which is 1. So like this we need to consider, okay, according to the formula. Now you can see here, follow this E and I. So E and I not matching, so maximum of these two is 0. Next E and N not matching, so maximum of these two is 0. Now E and T not matching, but what is the maximum of these two? 0 and 1 1. Now E and E, yes, matching. So then what you need to do? 1 plus what is the previous diagonal value? This one, right? Yeah, 1 plus, okay, whenever it is matching I'll write a diagonal here, okay, or else at the end also we can have, okay, matching like this. So 1 plus 1, which is 2 here. Now E and R not matching, so what is the maximum of 2 comma 1? 2. E and S, what is the maximum of these two? 2. Next E and here E, here T not matching, so maximum of 1 comma 2 is 2. Now the next part here, S here, S and I not matching, maximum of these two 0. S and T not matching, sorry, S and N not matching, so 0. Anyway, these things are not actually required. Why? Because when the increment started here, that means previous values, anyway you will get it as zeros. S and T, which is not matching, so 0 and 1, maximum is 1. Now you can see S and E not matching, maximum of 1 comma 2, which is 2. Now S and R not matching, 2 comma 2, what is the maximum? 2. Now S and S, yes, matching, means 1 plus maximum of, I mean 1 plus previous value diagonal here. So here 1 plus 2, which is 3. Now S and T not matching, what is the maximum of these two? 3. Now T and I, of course, not matching, 0, here 0, here T and T matching, yes, right? So matching, then 0 plus 1, sorry, T and T matching, so that's why 1 plus, what is 1 plus 1 plus 0? 1, right? Yeah. Now T and E not matching, so what is the maximum of 1 comma 2? 2 here. Okay, even you got 1 here which reflects nothing, right? So anyway you will get maximum here. So now T comma R, which is maximum of these two, which is not matching, so 2 only. Next T comma S not matching, 2 comma 3, what is the maximum? 3. Now finally t comma t, yes, matching. So 1 plus 3, which is 4. So like this we need to check it out, and finally what is the value we are getting? That is our longest common subsequence. So anyway we got the answer as 4. So like this we need to get the answer. Now we have to know, okay, we want to know what are those characters. Okay, what is that common subsequence? Anyway I said it as 4. What are those? How to get that one? Okay, here it is simple one. So whatever the answer you are getting it as 4. So you check it out, how this you are getting this 4. Is it from getting this maximum or by this 1 plus? Actually we need this one, right, whenever it is matching. So always check it out whether this is matching or not. Whenever it matches, then that value only you can check it out. So how did you get this one 4? So anyway it is from 1 plus, right? Yeah, so that's why now you are going back, right? So this diagonals only you have to check it out. When it is diagonal, take that character t. Now here also it is diagonal, so that's why take this character s. Now here is a diagonal, no, so go back here. So here it is a diagonal, so what is that? E. Now again it is a diagonal, so that's why t. That's it, over. So t E S T. So whenever you find this diagonal, only that part only, the column, the value, character you have to consider. That's it. Okay, that's why T E S T, which is your subsequence. That's it. Like this we need to get the answer. So even you can try for nest also, and here you can keep, again you will get it as 4. So what about R? That means rest. So you will get it as 3. So that part we'll do now. Okay, whether we'll get the answer or not. Yeah, I have taken here as a rest. Okay, yeah, same thing I'll take 0 1 2 3. So I have taken the values anyway with the same like zeros. Here I told you why to take these zeros. Then we have to start here, R and I. Yes, so not same, so maximum of these two, 0, R and N, 0, R and T, 0, R and E. Of course 0 and 0 is R and R. Now matching, so take the diagonal, 1 plus 0, which is 1. Next R and S not matching, maximum of these two 1, R and T not matching, 1 here. Now E and I not matching, so 0 0 0. E and N not matching, 0. E and T not matching, 0. E and E, yes, matching, so take here as 1. Now E and R not matching, so maximum of 1 comma 1, which is 1 only. E and S which are not matching, again maximum of 1 comma 1 is 1. E and T, what is the max? Again 1, right? So no matching. Now S value, you can see S and I not matching, so here 0. S and N not matching, so maximum of these two 0. S and T not matching, 0 and 0, maximum is 0. S and E again not matching, but 0 comma 1 maximum is 1. Now S and R, what is the maximum of 1 comma 1? 1. Now S and S, yes, matching, here S, here yes, matching. So 1 plus what you have to consider, the value here, previous value 1 plus 1, which is 2. So S and T not matching, what is the maximum of 1 comma 2? 2. Now the next one, T and I not matching, 0, maximum of these two. T and N not matching, maximum of these two 0. T and T, yes, matching, so 1 plus 0, which is 1. T and E not matching, maximum of 1 comma 1 only. T and R not matching, maximum of 1 comma 1 only. T and S not matching, 1 comma 2, what is the maximum? 2. T and T, yes, matching. Now 1 plus 2, which is 3. So the final answer we are getting it as 3. You can see what is that here. The answer is EST is our answer, which is a maximum is 3. So I said it as EST, right? So it's not 4 here. If you take R means there is an intersection, of course it is not a common subsequence, right? Only EST is a common subsequence, so the length is 3, right? Only 3 characters. Now how to find the length of that, how to find that subsequence? I told you. So from 3, so what is the diagonal you are going? Yes, T. Again diagonal you are going, so take S, but here it is not diagonal, then come in horizontal, so now it is diagonal, you can see, so E. So that's it, you are getting 0, right? That's it. So like this, anyway, these things, whenever where you are getting these diagonals, you are not getting. Why? Because they are not in the longest common subsequence, of course in sequence, but they are not in longest one. So that is what you have to consider. So EST is your answer. So like this, we need to check it out for longest common subsequence using dynamic programming approach. Anyway, what is the complexity? I have taken 2-dimensional array, so that's why if this is the length is m, this is the length is n, so the complexity is big of m into n. So that's it. If lengths are n into n, it may go maximum is n square, right? Yeah. So this is what about longest common subsequence. Hope you are able to get this one. So you can practice by taking another example also. We'll see the next problem in the next video lecture. Thank you.